Next, we have an epoxidation. And an epoxide is a new functional group to know. It looks like this. And it's basically an ether in a three-membered ring. So in an epoxidation, we're forming an epoxide from an alkene. So basically what we're doing is adding a single oxygen across the double bond. So say we take this alkene, I'm going to add a wedged phenyl group, and we're going to treat this with a reagent called MCPBA. And I'll show you what that is in a moment. And what this reagent does is it adds the oxygen across the alkene functional group. And when we're adding a single atom like that, it can add in one of two directions, from the front or the back. So if it adds from the front, both bonds will be on wedges. If it adds from the back, both bonds will be on dashes. And you can see we formed, in addition to our original chiral center, we formed new chiral centers. So in this particular case, because we started with a chiral center and made new chiral centers, we ended up with diastereomers. So the MCPBA stands for metachloroperoxybenzoic acid. Okay, well, what does that look like? We have a ring, the Cl, and then in a meta relationship that's 3 atoms away from the Cl, we have this peroxybenzoic acid. When you hear the peroxy term, think of 2 oxygens together. That's a peroxide. And this whole group here, where we have the 2 oxygens bonded to this carbonyl, this is a peroxy acid. And it's really the peroxy acid group that's doing the epoxidation. So you may even see a reagent like this written as RCO3H, and that stands for the peroxy acid. Like that. So in terms of the mechanism by which this adds, there's a bit going on, but it's a single step. So to keep it kind of simple, I'll just use a very simple alkene. And here is our peroxy acid. We have a hydrogen, an oxygen, and the carbonyl with an R group. And the way that this adds, it's actually this oxygen that gets incorporated into the product. The pi bond of the alkene will attack this oxygen. It will send these electrons over to here to form a double bond O. That will push these electrons here to take the hydrogen. And then finally, this bond, I'm going to draw this one in pink so we can keep track of it. This bond adds right here. Let me draw this pi bond in red. We'll track it as well. So in the product, then what we end up with, we have our pink bond to the oxygen coming from right here. Then we have a red bond from the oxygen that comes from the pi bond. And then the byproduct is a benzoic acid.